My dear students, welcome back to our channel. In this video, I will be explaining the BCA 5th semester subject Unix programming as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is Python objects, numbers. In Python, everything is an object: numbers, strings, lists, functions, even modules. Objects have types and methods, which means they can store data and perform actions. Numbers in Python. Python supports several types of numbers. 1. Integers, int, whole numbers. X is equal to 10. Y is equal to -5. 2. Floating point, float, decimal numbers. A is equal to 3.14. B is equal to -0.5. 3. Complex numbers, complex, numbers with real and imaginary parts. Z is equal to 2 plus 3j. Basic operations on numbers. X is equal to 10. Y is equal to 3. Print x plus y, number 13. Print x, y, number 7. Print x asterisk y, number 30. Print x, y, #3.3333. Print x%y, number 1. Python numbers are immutable, which means their value cannot change. Operations create new numbers. Easy way to remember. Python is equal to everything is object. Numbers are objects to use operations like plus, %. This makes Python simple, consistent, and easy to use, especially for calculations, scientific computing, and daily programming tasks. Next important short question is: 2. Differentiate between list and tuple. Lists and tuples are both used to store multiple items in Python, but they have key differences. Feature list tuple. Syntax square brackets, parentheses. Mutability: mutable can change, add, remove items. Immutable cannot change after creation. Performance: slower because they are mutable, faster, lightweight, immutable. Use case: when data may change, when data should remain constant. Methods: more built-in methods, append, remove, sort, fewer methods, count, index. Example: hash list. Fruits is equal to apple, banana, mango. Fruits.append, orange. Hash list can be changed. Hash tuple. Numbers is equal to 1, 2, 3. Hash numbers 0 is equal to 5. Hash error. Tuples cannot be changed. Easy way to remember. List is equal to mutable, changeable. Tuple is equal to immutable, fixed. Tip: use tuples for constant data and lists for flexible data in your programs. This makes Python efficient and easy to manage, especially when working with large data sets. Next important short question is 3. What are Python modules? A module in Python is a file containing Python code, functions, classes, variables that you can reuse in other programs. Modules help you organize code, avoid repetition, and make programs manageable. Why use modules? Reuse code across programs. Avoid rewriting common functions. Organize code logically. Using modules. You can import a module using the import keyword. Example: using the math module. Import math. X is equal to 16. Print math.sqrt, kiss smiley, hash output 4.0. Print math.py, hash output 3.14. Math.sqrt, square root function. Math.py, constant pi. Creating your own module. Create a file mymodule.py. Definite greet name. Print hello plus name. Use it in another program. Import mymodule. Mymodule.greet Rahul output hello Rahul. Easy way to remember. Module is equal to toolbox. Python modules are like toolboxes containing ready-to-use tools, functions, variables, classes. You import a toolbox whenever you need it, instead of making everything from scratch. This makes coding faster, cleaner, and organized. Next important short question is: 4. Object-oriented programming. Object-oriented programming, OOP, is a way of writing programs using objects and classes. It helps organize code, reuse it, and model real-world things. Key concepts. 1. Class, a blueprint or template for creating objects. 2. Object, an instance of a class with its own data and behavior. 3. Attributes, variables inside an object. 4. Methods, functions inside an object. Example. Define a class. Class car. Definite __init__ self, brand, color. Self.br and is equal to brand. Self.color is equal to color. Definite drive, self. Print, self.br and plus is driving. Create an object. My_car is equal to car, Honda, red. My_car.drive, output, Honda is driving. Car class. My_car object. Drive method. Easy way to remember. Class is equal to blueprint, object is equal to real thing. Think if class is a recipe, object is the cake. OOP makes Python structured, reusable, and easy to manage, especially for big projects. Next unit 5. Long questions. First important long question is: define string. Explain various string methods with suitable examples. In Python, a string is a sequence of characters enclosed in single quotes, double quotes, or triple quotes. Strings are used to store text like names, messages, or any sequence of characters. Example of strings. Name is equal to Rahul. Greeting is equal to hello. Multi_line is equal to this is. A multi-line string. Strings in Python are immutable, which means you cannot change a string directly after creating it. Any operation returns a new string. Common string methods. 1. Lay returns the length of the string. Print lay name output 5. 2. Lower and upper convert string to lowercase or uppercase. Print name.lower Rahul. Print name.upper Rahul. 3. Strip removes extra spaces from the start and end. Text is equal to hello. Print text.strip hello. 4. Replace old, new, replace a substring. Print name.replace Rahul, Amit Amit. 5. Split string into a list based on separator. Sentence is equal to I love Python. Print sentence.split I love Python. 6. Join a list of strings into a single string. Words is equal to I love Python. Print .join words I love Python. 7. Find the index of a substring. Print name.find number 2. 8. Starts with and ends with check beginning or ending. Print name.starts with true. Print name.ends with true. Easy way to remember. Strings is equal to text data. Methods is equal to tools to change, find, split, or join strings. Think of a string as a rope of letters and methods as scissors, glue, or magnifying glass to work with it. Using string methods makes Python programming fast, neat, and effective for handling text, messages, and user inputs. Next important long question is: to explain mapping and sets in Python. Python provides special data types to store and manage collections of data. Two important types are mapping and set. 1. Mapping, dictionaries. A mapping in Python is called a dictionary, dict. It stores data in key-value pairs. Each key is unique, and values can be any data type. Dictionaries are mutable, so you can change, add, or remove items. Example: student is equal to name Rahul, age 20, course Python. Print student name hash output Rahul. Student age is equal to 21 hash update value. Student grade is equal to a hash add new key value. Print student. Common methods. Keys returns all keys. Values returns all values. Items returns key value pairs. Easy way to remember. Think of a dictionary as a real-world dictionary. Key is equal to word, value is equal to meaning. 2 sets. A set is an unordered collection of unique elements. Sets do not allow duplicates and are mutable. Useful for operations like union, intersection, difference. Example: fruits is equal to apple, banana, mango, apple, hash duplicate ignored. Print fruits, hash output apple, banana, mango. Hash set operations. A is equal to 1, 2, 3. B is equal to 3, 4, 5. Print A dot union B hash 1, 2, 3, 4, 5. Print A dot intersection B hash 3. Print A dot difference B hash 1, 2. Easy way to remember. Sets is equal to unique items only. Dictionaries is equal to key-value pairs. Why use them? Dictionaries, quick lookup of data using keys. Sets, remove duplicates and perform mathematical set operations. By understanding mappings and sets, Python programmers can handle data efficiently, avoid repetition, and perform operations quickly, making programs faster and cleaner. Tip: think dictionary is equal to labeled boxes, set is equal to unique collection of things. This visualization makes them easy to remember. Next important long question is: 3 conditionals and loops. In Python, conditionals and loops help control the flow of a program. They decide what code runs and how many times. 1. Conditionals. Conditionals let your program make decisions using if, elif, and else. Syntax: if condition. Hash execute if condition is true. Elif another underscore condition. Hash execute if another underscore condition is true. Else. Hash execute if all conditions are false. Example: marks is equal to 75. If marks is equal to 90. Print excellent. Elif marks is equal to 60. Print good. Else. Print needs improvement. Output good. Easy way to remember. If is equal to check first condition. Elif is equal to check next condition. Else is equal to fallback if all fail. 2 loops. Loops allow repeating code multiple times without writing it again. Python has for loop and while loop. For loop iterate over a sequence, list, tuple, string. Fruits is equal to apple, banana, mango. For fruit in fruits. Print fruit. Output: apple, banana, mango. While loop repeat until a condition is false. I is equal to 1. While I happy smiley 5. Print I plus is equal to 1. Output 1 to 3 4 5. Loop control statements. Break exit loop. Continue skip current iteration. Pass do nothing. Example with break continue. For I in range 1, 6. If I is equal to 3. Continue hash skips 3. Print I. Output 1 to 4 5. Easy way to remember. Conditionals is equal to decision making. Loops is equal to repetition. Think if is equal to choose path. Loop is equal to keep walking the path until done. Using conditionals and loops makes Python programs smart, efficient, and able to handle multiple scenarios without rewriting code. Next important long question is 4. Explain about file input-output in Python. File input-output, I/O, in Python is used to read data from files and write data to files. Files are important for storing data permanently, unlike variables which disappear when the program ends. 1. Opening a file. Use the open function to open a file. Syntax. File is equal to open, filename.txt, mode. Modes. R. Read, default. W. Write, creates new file or overwrites. A. Append, add at the end. RB, WB, read write in binary mode. 2. Reading from a file. Read entire content. Read line, read one line at a time. Read lines, read all lines into a list. Example. File is equal to open, sample.txt, R. Content is equal to file.read. Print, content. File.close. 3. Writing to a file. Write text. Write lines, write list of lines. Example. File is equal to open, output.txt, W. File.write, hello, Python \n. File.write, file I/O is easy. File.close. 4. Using with statement, recommended. With open, sample.txt, R as file. For line in file. Print, line.strip. Automatically closes the file. Safer and cleaner. 5. Easy way to remember. Open file, read write close file. Think file is equal to book, open is equal to start reading writing, close is equal to finish. Why file I/O is important? Store program output. Read data for analysis. Keep records or logs. Works with text or binary files. By understanding file I/O, Python programmers can handle external data, automate tasks, and save information efficiently, making programs practical and powerful. Next important long question is 5. Demonstrate the use of exception handling in Python. In Python, an exception is an error that occurs during program execution. Examples include dividing by 0, file not found, or invalid input. If exceptions are not handled, the program stops abruptly. Exception handling allows your program to catch and handle errors gracefully, keeping it running smoothly. 1. Try except block. The most common way to handle exceptions is using try and except. Syntax. Try. Hash code that may cause an error. Except some error. Hash code to handle the error. Example. Try. Num is equal to int, input, enter a number. Result is equal to 10 num. Print, result. Except 0 division error. Print, error, cannot divide by 0. Except value error. Print, error, invalid input, enter a number. If the user enters 0, cannot divide by 0. If the user enters a letter, invalid input, enter a number. To else and finally. Else runs if no exception occurs. Finally always runs, used to release resources. Example. Try. File is equal to open data.txt r. Content is equal to file.read. Except file not found error. Print, file not found. Else. Print, content. Finally. Print, program completed. 3. Raising exceptions. You can also raise your own exceptions using raise. Age is equal to -5. If age 0. Raise value error, age cannot be negative. Easy way to remember. Try is equal to test risky code. Except is equal to catch errors. Else is equal to run if no error. Finally is equal to always run. Think, try your luck, catch problems, do good stuff if safe, and clean up always. Why use exception handling? Prevent program crashes. Handle unexpected inputs. Make programs robust and user-friendly. Using exception handling, Python programs can deal with errors smartly, making them reliable and professional. Next important long question is 6. Functions and functional programming. In Python, a function is a block of code that performs a specific task. Functions help organize code, avoid repetition, and make programs easier to read and maintain. 1. Defining a function. Use the definite keyword to define a function. Syntax. Definite function _name parameters. Hash code block. Return value. Example. Definite greet name. Return hello plus name plus. Print greet Rahul hash output hello Rahul. Greet function name. Name parameter. Return sends output back. 2 types of functions. 1. Built-in functions provided by Python, example, lay, print. 2. User-defined functions created by the programmer. 3. Anonymous functions, lambda, small one-line functions. Square is equal to lambda x, x asterisk x. Print square, 5, hash output, 25. 3. Functional programming in Python. Python supports functional programming, a style where functions are treated as first-class objects. Key concepts. Passing functions as arguments. Returning functions from functions. Using map, filter, reduce. Example, using map. Numbers is equal to 1, 2, 3, 4. Squared is equal to list, map, lambda x, x asterisk asterisk 2 numbers. Print squared, hash output 1, 4, 9, 16. 4. Easy way to remember. Function is equal to reusable block of code. Functional programming is equal to using functions like building blocks. Think, write once, use many times. Treat functions like Lego pieces to build complex programs. Why functions are important? Avoid duplicate code. Make programs modular. Help in debugging and testing. Make programs readable and scalable. Using functions and functional programming, Python programmers can write efficient, clean, and professional code, making even large projects easy to manage.